The present module is on probability distributions. Probability distributions are expectations on the probable nature of distribution of various events in a universe or population. Probability distributions can be called expected frequency distributions and are computed based on probability theory. It is the expectation on probable behavior of a distribution. The most popular probability distributions include binomial distribution, Poisson distribution, and normal distribution. Binomial distribution is a discrete frequency distribution. Normal distribution is a continuous frequency distribution, and Poisson distribution is a limiting form of binomial distribution. Then, first we shall see binomial distribution. Binomial distribution is also known as Bernoulli distribution in the name of the Swiss mathematician James Bernoulli, who was instrumental in developing binomial distribution. Binomial distribution is a probability distribution expressing the probability of one set of dichotomous events, that is, success and failure. For example, if a coin is tossed once, there can be two outcomes, the head or the tail. In a particular toss, the chance of obtaining a head is 1/2 and the probability of getting a tail is also 1/2. If the probability of obtaining head is P and the probability of obtaining tail is Q, P is equal to 0.5, Q is equal to 0.5 and P plus Q is equal to 1. P and Q are called the terms of the binomial P plus Q. And if you illustrate with an example, if you are tossing two coins A and B simultaneously, there are 4 outcomes that are possible. You may get head in the case of coin A and coin B, head in the case of coin A and tail in the case of coin B, tail in the case of coin A and head in the case of coin B, and tail in the case of both coin A and coin B. And if you are finding out the corresponding probabilities of these results, you can arrange it like this: two heads, HH, head and tail, HT, tail and head, TH, and two tails, TT. And if P is the probability of obtaining head and Q is the probability of obtaining tail, the probability of obtaining two heads together can be plotted as PP, probability of getting a head and tail as PQ, and probability of getting tail and head as QP, and the probability of getting two tails as QQ. And when you are summing up the values, you will get P squared, 2PQ, and Q squared. Or in other terms, 1P square, 2PQ, and 1Q square. These are called the terms of the binomial P plus Q all squared. P plus Q all squared is equal to P squared plus 2PQ plus Q squared. And we know that P plus Q is equal to 1. If you toss a coin, you will get either a head or a tail, means P plus Q is equal to 1, and P plus Q the all squared is equal to P squared plus 2PQ plus Q squared, and that is also equal to 1. And if you are substituting the values of P and Q, P is equal to 0.5 and Q is equal to 0.5, if substituted in the binomial, 0.5 plus 0.5 the whole square is equal to 0.25 plus 0.5 plus 0.25, it is equal to 1. Then you can see the binomial theorem. The binomial theorem explains how to expand the expressions of p plus q raised to n. The formal expression of the binomial theorem is given. So, binomial theorem is p plus q raised to n, and now we may see how we will find out the terms of the binomial. The first term of the binomial p plus q raised to n is p raised to n always. The second term is n p raised to n minus 1 q, and in each succeeding term the power of p is reduced by 1 and the power of q is increased by 1. And the coefficient of the first term will be 1, and the coefficient of any term is obtained by multiplying the coefficient of the preceding term by the power of p in that preceding term and dividing the product so obtained by 1 more than the power of q in that preceding term. If I repeat, the coefficient of any term is obtained by multiplying the coefficient of the preceding term by the power of p in that preceding term and dividing the product so obtained by 1 more than the power of q in that preceding term. And for example, let us find out the terms of the binomial p plus q raised to 4. Here n is equal to 4 means there will be 5 terms in the expansion. And the first term is p raised to n, it is equal to p raised to 4, since n is equal to 4. The second term is n p raised to n minus 1 q, it is equal to 4 p cubed q. The third term you can find out like this, 4 into 3 by 2 will be giving you the coefficient. 4 is the coefficient of the previous term, 3 is the power of p in that particular term, and 2 is obtained by adding 1 with the power of q. Here the power of q in the previous term is 1 plus 1 it is equal to 2. So when you are finding out the term, you will get 6p squared q squared. And then the fourth term is again calculated. To calculate the fourth term, the coefficient of the fourth term, it is 6 into power of p 2 divided by 1 more than the power of q, that is 3. So when calculated, it comes to 4pq cubed, and the fifth term is 4 into the power of p 1 divided by 1 more than the power of q 4, and when calculated it comes to q raised 4. Now we can see certain general relationships found in the binomial expansion. In a binomial expansion, as we have already seen, the number of terms in a binomial expansion is always n plus 1. the exponents of P and Q for any single term when added together will give the sum of n. The exponents of P will be in the order n, n-1, n-2, n-3, reaching up to 1 and 0. And the exponents of Q will be in the order 0, 1, 2 and moving up like n-1, finally ending in n. And you have to bear in mind that P raised to 0 is equal to 1 and Q raised to 0 is equal to 1. The coefficients of the terms of a binomial distribution are always symmetrical. They ascend to the middle of the series and then descend. There are n plus 1 terms and the coefficients of the first term and the last term will be 1. Now let us discuss the properties and constants of the binomial distribution. The shape and properties of binomial distributions change as P changes for a given n or n changes for a given P. As P increases for a fixed n, the binomial distribution shifts to the left. The mean of the binomial distribution is NP, n into P. The standard deviation is square root of NPQ and of course variance is NPQ. Then about the importance of binomial distribution. Binomial distribution is a discrete probability distribution that is useful in describing a variety of events. It is binomial since we are dealing with two probabilities of event A and event B that are discrete in nature with no intermediates. When there are three types of events, it becomes a trinomial and instead of P plus Q is equal to 1, it becomes P plus Q plus R is equal to 1 and P plus Q plus R all squared also can be expanded, which will also be equal to 1. When the number of types of events increase further, it becomes a polynomial. We can say that a binomial equation is a type of polynomial. We can say that a binomial equation is a type of polynomial equation when there are only two types of events. Then, something about fitting a binomial distribution. When a binomial is to be fitted to observed data, the following steps are adopted. The first step is determining the values of P and Q. If one of them is known, the other can be calculated using the formula Q is equal to 1 minus P. When P and Q are equal, the distribution is symmetrical, and if they are unequal, the distribution will be skewed. The next step is the expansion of the binomial P plus Q raised n, and in the next step, we have to multiply each term of the expanded binomial by n, which is the total frequency of events in that particular experiment. And now let us see the formula for calculating the number of experimental outcomes providing x successes in n trials. There are n number of trials and we have to find out the probability of x successes. And the formula is Px is equal to n factorial divided by x factorial into n minus x factorial into P raised x 1 minus P raised n minus x. And in the formula, P stands for the probability of success. N is equal to the total number of events. X is equal to value of the random variable's success. X is equal to the value of the random variable success. And let us see one example. A problem is given to you. In a chest clinic, it has been observed that 20% of the patients who visit the clinic on a day suffer from chronic asthma. If on a day 5 patients visited the clinic, what is the probability that 3 of them will be suffering from asthma? Here x is equal to 3, n is the total number of patients 5, p is given, it is 20%, it is equal to 0.2. And the formula to be used is Px is equal to n factorial divided by x factorial into n minus x factorial into p raised to x into 1 minus p raised to n minus x. So substituting the values, you get 5 factorial divided by 3 factorial into 2 factorial into 0.2 raised to 3 into 0.8 raised to 2, and you get 5% as the final value, 0.05 which is equal to 5%. It means that there is 5% probability that 3 patients out of the 5 will suffer or are suffering from chronic asthma. And there is another example given. In a survey, it was found that all the 4 children born to a couple were blind. What is the probability that all the children are female? There are 4 children in a family. They are, unfortunately, all of them are blind. And we are asked to find out what is the probability that all the children are female. And there are 4 children. The binomial equation here will be p plus q raised to 4, and when expanded it will be p plus q raised to 4 is equal to 1 p raised to 4 plus 4 p cubed q plus 6 p squared q squared plus 4 p q cubed plus 1 q raised to 4. And if you are taking the ratio of the coefficients, it is 1 is to 4 is to 6 is to 4 is to 1. Q raised to 4 stands for the condition that all the children are female. Here we consider P as the probability of males and Q as the probability of females. And it is as per the expansion of the binomial p plus q raised to 4. Q raised to 4 is the last term of the expansion, and it is 1 q raised to 4. And there are in the ratio, the total of all the terms is 16. So q raised to 4 stands for 1 by 16 of the total of the coefficients, and when 1 is divided by 16, it is equal to 0.0625. It is equal to 0.0625, which is equal to 6.25%. It means that the probability of all the 4 children are female is 6.25%. So that was about binomial distribution, and now we are moving to Poisson distribution. Named after Simon Dennis Poisson, Poisson distribution is a type of discrete frequency distribution which is the limiting form of a binomial distribution. It is used to describe the distribution of rare events. In other words, it is the limiting form of binomial distribution as n becomes large and p approaches 0. For example, if we consider the probability of a cell of a large population of cells getting mutated, you can calculate the probability of mutation and the rate will be low, and mutation here is a rare event. Poisson distribution is expected when the chance of any individual event becomes small, and because of that, it is also called the law of improbable events. Probability of rare events like floods, accidental release of radiation, etc. can also be described using Poisson distribution. Poisson distribution has also been defined as discrete probability distribution of the number of events of a particular type occurring in a given time or space. Now let us see the formula for Poisson probability function. Px is equal to mu raised x into e raised minus mu divided by x factorial, where mu is the expected value or average number of occurrences in an interval, and it is calculated using n into p, and e is a constant, is equal to 2.71828. It is called the Euler's number, and it is the base of the natural logarithm. And e raised minus u is usually obtained from statistical tables. Now let us see an example of finding out Poisson probability function. It is reported that the death rate of asthma patients during anesthesia is 0.005. What is the probability that 2 patients will die when 1000 are anesthetized? The formula is Px is equal to mu raised x into e raised minus mu divided by x factorial. And here x is the expected frequency of that particular event. X is given as 2. What is the probability that 2 patients will die? So x is 2. P is equal to, P is given, expected probability of occurrence of P, it is equal to 0.005, and n is the total number, and it is equal to 1000. Mu is equal to n into p, that is 1000 into 0.005, it is equal to 5. E raised minus mu is 2.71828 raised minus 5, and either when calculated or from the statistical tables, you will get it as 0.0067. So Px is calculated here, substituting the values in the formula, and you will get it as 0.08. It means that there is 8% chance that 2 patients will die when 1000 are anesthetized. Then comes the third type of probability distribution, normal distribution. And as we have already seen, binomial distribution and Poisson distribution were discrete frequency distributions. They were dealing with discrete events, the frequencies or the probabilities of discrete events. And normal distribution is dealing with continuous events. And normal distribution was first described by Binomial in 1773, and subsequently several efforts were made by statisticians to establish the normal model as the law ruling all continuous random variables. Normal distribution describes the distribution of continuous variables as we have seen earlier, and you can say that normal distribution is an approximation of binomial distribution. Whether or not P is equal to Q, binomial distribution tends to the form of a continuous curve. The limiting frequency curve obtained as n becomes large is called the normal frequency curve. Now let us see the importance of normal distribution. Normal distribution makes it possible to determine the minimum and maximum limits within which the population values lie. Within a range of mean plus or minus 3 sigma, mean plus or minus 3 standard deviation, 99.73% or almost all the items of the distribution lie if the curve is symmetrical. As n becomes large, normal distribution serves as a good appropriation of many discrete distributions. In theoretical statistics, many problems can be solved only under the assumption of a normal distribution. Normal distribution has several mathematical properties that make it popular and easy to manipulate. So now we can see the properties of normal distribution. The normal distribution curve is symmetrical about the mean. The height of the curve is maximum at the mean. The height of the curve declines as it goes in either direction. The curve approaches nearer and nearer to the base on either side, but it never touches the base. Since there is only one maximum point, the normal curve is unimodal. Mean plus or minus 1 sigma, mean plus or minus 1 standard deviation covers 68.27% of the area under normal curve. Mean plus or minus 2 standard deviation covers 95.45% of the area under normal curve, and mean plus or minus 3 standard deviation covers 99.73% of the area under normal curve. And there are certain conditions for normality. The variable behaves normally under the following conditions. 1. The causal forces must be numerous and of approximately equal weight. 2. These forces should be the same all over the population. 3. These forces must be independent of one another. 4. The operation of the causal forces must be in such a way that deviations above the mean are balanced by deviations below the mean. Applications of normal distribution. There are several applications for normal distribution. 1. To fit a distribution under certain conditions. 2. To approximate the binomial distribution and other discrete or continuous probability distributions under suitable conditions. 3. To appropriate the distribution of means and certain other quantities calculated from samples, especially from large samples. Now let us see how we can calculate the probability density at any value of x. Calculation of probability density at any value of x. Fx is equal to 1 divided by square root of 2 pi sigma squared into e raised minus x minus mu the whole squared divided by 2 sigma squared. Here pi, as we know, it is 3.14159, e is equal to 2.71828. X is the value of x, the expected value of x, mu is the mean, and sigma is the standard deviation. And then we have to know something about standard normal distribution so that you can apply normal distribution more effectively. For normal distribution, the curve will be symmetrical or bell-shaped. The shape of the normal curve is determined by the mean and the standard deviation of the distribution. For any given standard deviation sigma, there can be a number of normal curves, each with a different mean or mu. For any given mu, there can be a number of normal curves with a different sigma also. To compare the distributions, usually the normal variable is transformed into a standard normal distribution. The standard normal variable is denoted by z. Z is equal to x minus mu divided by sigma. When x is equal to mu, z is equal to 0. When x is equal to mu plus sigma, z is equal to 1. And z is the number of standard deviations from the mean at which the value of x is calculated or the x is located. Z is positive if x is greater than mu, if x is greater than mean, and it's negative when x is lesser than mean. Now let us see an example, a situation under which we are applying the standard normal distribution. An example, height of adult men are supposed to be normally distributed with a mean of 165 centimeter and standard deviation of 5. Find out the proportion of men with heights above 170 centimeter. You have to find out the position of x, or you have to find out z. Z is equal to x minus mu divided by sigma. You have to find out the value of z first. Z is equal to x minus mu divided by sigma. And here x is 170, mu is the mean, it is 165, and sigma is the standard deviation, it is 5. So substituting in the formula for x, substituting in the formula for z, you get z is equal to 170 minus 165 divided by 5, it is equal to 1. And z tables are available, and from z tables you can see that for z is equal to 1, the area under the standard normal curve above mean for one standard deviation, of course below mean also, is 0.3413. It means that in the distribution, you know that mean is the central value if it is a symmetrical distribution, and 50% of the values lie above the mean value, above the central value, and 50% of the values of x lie below the central value. And in the case of z, when z is equal to 1, or for one standard deviation, the position of x is at 0.3413. 0.3413. It means that the remaining, total it is 0.5, the remaining 0.1583 part comes above the standard deviation, above one standard deviation. Here it is the value or the heights above 170 centimeter, because 165 is the mean, 165 plus 1 standard deviation gives 170. So you can see that out of the 50% above the mean of the distribution, 34.13% comes within one standard deviation, and the remaining 0.1587 comes above the and the remaining 15.87% comes under 15.87% comes above one standard deviation. Hence 15.87% of the men in the population are with a height above 170 centimeter. Similarly, you can calculate the expected probability of people in the distribution above 175 centimeter. Since 5 is the standard deviation, 175 means mean plus 2 standard deviations, and the area under the standard normal curve above mean plus 2 standard deviation is 0.4772 or 47.72%. It means that the area of the curve above 0.4772 is represented by men with height above 175 centimeter, and their probability is 0.0228, means it is 0.5 minus 0.4772. It is equal to 0.0228. It is equal to 2.28%. So that also you can calculate. In this way, you can calculate mean plus or minus 3 standard deviation also. So now we have seen the different types of probability distributions. Probability distributions are otherwise called expected frequency distributions because they are predicted based on the probability theory, and there are discrete expected frequency distributions or discrete probability distributions and continuous probability distributions, normal distribution and binomial distribution and Poisson distribution are examples for discrete probability distributions. A normal distribution is an example for continuous probability distribution. And also we have seen different conditions under which you can use the distribution functions. You can calculate the values, the frequencies of x at different positions, and also you can use the information for a lot of computations in your studies, research, and of course in your practical life also. Thank you very much.